Hi, let's take a few minutes and talk about file names in Unix, Linux, and just a couple of rules and things that you're typically going to see. This discussion is by no means exhaustive and it's going to cover everything, but it is going to talk about a few things that are basic. So first of all, in my example here, I'm just sitting in my home directory, and if I do a simple ls, I see a list of file names. Of course, there are more than files in here. These are files and directories as well. File names in Linux really have virtually no restrictions as to what makes a legal file name. Your files can contain alphanumeric characters, special characters, underscores, dots, etc. The one exception is that the slash, the / character itself, cannot be part of a file name, since that's the separator, as you know, between directories. So we have a list here, and in the bash shell, for example, there is a little bit of friendly color coding that goes on so that all of my directories actually show up in blue here. I can also do a ls in the long version, and I can also tell that these blue entries, if you will, are also our directories because of the D that's there in the very leftmost column. We've seen that before a little bit, talking about the ls command. In terms of the length, most distributions have a minimal nominal length of 256 characters, which is generally a lot more than anybody ever needs. But there is no specified POSIX restriction to that. There's no reason to have a limit on them. It's more of a practical limit if you're going to be typing things, obviously. So those names get to be can get to be a bit long. Special file that you want to know about, however, is are files that begin with a dot character. Now you notice that in this example in front of you there is a file called examples.desktop. And in this example, by the way, the dot is not the first character. It's embedded in the file name, and it has no special meaning. Although in typical usage, programmers and designers like to use the dot to separate parts of the file just for the sake of readability. And we'll also talk a little bit later about extensions and how they tend to have meanings. For example, files that are Java source files tend to end in .java. C files tend to end in .c. Header files .h, etc. But there are also files that begin with a dot, and if they're in there, they are what are typically known as hidden files, and they won't show up by default. However, if you do an ls -a, and where the A option means show all files, you'll see that I get a very different listing here. I have a whole bunch of files like .bash history, .bash logout. There are some that are like .cache, .config, .dbus. These are all actually directories that themselves are hidden. The reason for this is that these are files and directories that a lot of programs need to use, but they're not of typical day-to-day interest to a user, so by default they don't show up. If I wanted to list just those files that were dot files, I could say something like ls .star. And we're going to talk in a minute about this, about the star as the wildcard character. And this says, show me every file that begins with a dot and is followed by anything else. And if I do that, you'll see I get a list of things. Although the listing's a little bit different, because what he's actually doing, a lot of stuff scrolled off the screen here, is that I'm seeing not only the dot files, but if they were directories, ls by default goes ahead and shows me what's inside of those directories. It kind of does a one-level expansion, if you will. And that's sometimes useful, sometimes not. One way to get around that is to do an ls and use the -d character that says show directories only as directories, and say .star. So ls -d .star says show me all files that begin with a dot. And if they're directories, just show me the directory name, don't expand them. Okay, a couple other things. You can have spaces in file names. Linux and the later versions of all the shells will in fact tolerate this. You and I, working at the command line, probably will not use that a lot. Let's see if I can find, I think in my music directory, I think I might have. I don't have anything. Let's go to video, for example. go into my videos directory. Here's a good one. Okay, I have a directory here of Archer Season 1, a cartoon that I like to watch. So you notice that that one directory, in fact, if I do a long listing, you'll see that, oh yeah, Archer Season 1 is a directory. Notice that its name has spaces in it. Now this is often problematic at the command line because the space is usually used by the shell, for example, to interpret one argument versus an extra, parse out parts of commands. If I use the file name completion, this will shed a little bit of light onto how Linux actually deals with this. So here I did an ls and I started to type Archer and I hit the tab key. Notice now that he prints out the Archer Season 1 in the file name completion, but after the R there's a backslash followed by the space. That backslash is a standard escape character, and by escape that character simply means take the next character and treat it literally. Do not interpret it to have any kind of special meaning. In this case, the space might have special meaning in that it's reserved to separate one part of a command from another, for example. So I can do an ls on that, and in fact, it shows me what's in that directory, and if I even went ahead and did a cd into it and did an ls, you'll see that all the files in there also happen to be Archer Season 1, Episode 4.avi, etc. And let's see if I said Episode Season 01 E01 and then completed it. Once again, you'll see that I get the slash character, the backslash rather, as an escape. You and I at the command line will probably not use spaces very much because frankly, they're just difficult to deal with and clumsy to type with. However, since so much of data that we get is external to, potentially external to a Linux system, such as things you might download from the internet, as these files are, you have to have a way to deal with them. So since Windows, for example, so freely allows you to use spaces in file names, and it's a very nice thing to use when you're trying to give descriptive names to files out of GUIs, we have to have a way to support these, at the command line. So that's what that's all about. Let's look ahead at one other issue about wildcards. I have an example here in a directory I have called results, and we'll just do a listing and take a look at that. Now here's a set of file names that look really long. And this is actually not unusual at all. These are actual files from a project I'm working on where we have a testing application, and the tests are testing things called pixels in a web application. And so every time I run my automated test, it generates a log file where all my informational messages about the test go. So these files are actually created by another program. They're not created by a user. But when I run my test apps, I get a test all pixels and then some bunch of characters that follows. If you take a second and look at that, they'll probably should start to make some sense to you. For example, test all pixels 20110214. Okay, that's the year, month, and day. So that very first file was, these are timestamp datum, and we see that that's in year 2011, in February 14th. The .110340 was actually that test was kicked off at 11:03 and 40 seconds in the morning, and the last 6 characters are actually a millisecond count. They're just thrown in there to try to keep things unique, so that if I executed, let's say I kicked off 4 or 5 tests, one right after the other within the same minute, or even with less than a second, if they got executed, I'd still have a unique name. The .log at the end is simply something that we use in our system to say it's a log file. I mean, it's kind of self-explanatory, but it's really there for human readability. It doesn't have any direct meaning to the system. I can, of course, do a long listing on this if I want to see some things about these files. That's a really long list. Let me do an ls-l. let's just do a plain ls for a second. What I want to show you is the idea of wildcards. For example, if I wanted to do a long listing of all the files that were test all pixels that were only done in on 2.14. So I could say test all pixels 00020110214, and then I could use the character star at the end. And you'll notice, in fact, I'll just do a plain listing and not a long listing just to get things to look a little nicer. And you'll see that I have files that are all 2011-02-14. If you look at the original list for a second, you'll see that those last ones, there are some files that were run on March the 3rd, 0303. So if I run this with the star, that says show me all files that contain this string followed by anything. So that's a wildcard. And actually it's a pretty powerful thing because I can apply this not only to an ls command, I can use it to any Linux command that expects a file name. For example, the rm command to remove a file. If I did this command with an rm instead of an ls, it would delete all files that contained that February 14th timestamp. So it can be really powerful, and as an important reminder, there's no such thing as an undo, or from the command line, there is no trash bin or recycle bin. Once you remove a file, kiss it goodbye, it's gone. So you learn to get real careful and check things. I'll show you later in a later screencast how to set some environment variables that keep you from clobbering things, for example. So this is just a quick overview of file names, what's legal, and how wildcards are used. And there'll be more to come. Thanks for your time, guys. Bye now.